another beautiful morning and I'm headed to Zurich to work with Robert from the DFINITY team. I just finished an essay that I had to send in and I was 2 days behind the deadline, and I realized there's still moments where I struggle getting stuff done. The number one thing that helps me make progress is if I don't try to make it perfect, but if I just try to make a first draft and then send that to someone for review. So in this case, Elena was a great sparring partner. I wrote an initial version, sent it to her, she did a rewrite and then sent it back to me, and I could do the final rewrite. So having this like iterative process really helped me, and I think it's something that can help with any kind of challenge. It's writing a business plan or coming up with a strategy for how to invest or planning a trip. I think this MVP thinking, like just get a first rough draft out there and then have someone else improve it and then get it back, it's really, really powerful. So this right here is Paradeplatz, which is kind of like the center for banking. This new crypto co-working space. It's just a few hundred meters away from it. We're at Trust Square, which is a co-working space for blockchain companies or companies that are close to a blockchain or crypto space. It's on Bahnhofstrasse, one of the most famous streets here in Zurich. Today I'm here with Robert. Where is he? Here. Who is our researcher here in Zurich. I always enjoy sitting down with him because he has capabilities to really drill down on theory and algorithms and really figure out stuff that I can't. I want to use this opportunity to talk a bit about DFINITY, what it is, and how it's different from everything else that's out there. In general, DFINITY could be described as building a world computer. So it's not just a currency, it's not just a token, but it's in first priority a platform to build and run applications. How is consensus in DFINITY different from most other platforms?
So most other platforms are based on a simple chain-based system where miners build blocks, and after a certain number of blocks, a transaction that was included in a block that got confirmed like 10 times can be considered as final or as probably final. Whereas in our system, with DFINITY, there are not only miners who build blocks, but we have other roles in the system, like notaries. The notaries come together and they notarize blocks, and once such a common notarization has been produced on a block, the block has a higher trust in it. And we can prove in our system that with 2 notarizations plus a small delay, a block can be considered as final, so it cannot be reverted.
Among other things, what that means is that where in Bitcoin finality is probabilistic, often people say 6 blocks is reasonably secure that the transaction is actually final, which means anywhere between an hour and about 2 hours, right, with current block times. In DFINITY, that time is much, much shorter because after just 2 confirmations or 2 blocks, we have absolute certainty that the transaction is final. So DFINITY is not live yet. We're working towards a launch as we speak, but that's going to happen within the next few months. Based on the testnet and the configurations that we're currently running, what is a block time that we can expect?
I think we can expect a block time around 2 seconds. We have to test it in the real world, but we have already achieved 1 second block time in our test environment. Like with 2 seconds, if we say that we need 2 confirmations and like some delta or some delay after it, we can achieve like finality after 5 seconds.
So that's compared to Bitcoin, where it's between 1 hour and 2 hours, and what's commonly accepted finality time on Ethereum?
About 10 minutes. They need much more confirmations. They need like 40 or 50 confirmations, but they have a much smaller block time than Bitcoin, so they are faster than Bitcoin.
So Bitcoin about 1 to 2 hours, Ethereum about 10 minutes, and on DFINITY, finality time will be somewhere around 5 seconds, most probably. What are other big differences? One of them is our consensus mechanism, which is considered to be a proof of stake algorithm versus proof of work. Proof of work means that in order to determine who signs the next block and gets the mining reward, solves the riddle, whereas proof of stake is a newer concept and not as easy to achieve. How does proof of stake work in DFINITY?
Proof of stake system, you have the problem of how can you determine who should be the next miner, who should create the next block. So because that process of choosing the next miner should be unmanipulable, and in DFINITY we have a system called threshold relay where we have a random beacon which creates a source of randomness which is unmanipulable, unpredictable, and at the same time deterministic. And this allows us to get a list of block producers for every block round, which is completely random.
When I talk about proof of work, as an example, for the riddles, I use something like Sudoku or Rubik's Cube, meaning it's just some sort of riddle that a lot of people try to solve at the same time, and it's kind of random who solves it first, because the assumption is everyone has similar capabilities, and that's how it randomly choose this one person that signs the block. Is there a simple analogy for how this random or this like threshold relay or random beacon works?
Group of 400 nodes, they come together and each of them create some sort of special signature on the previous output of the random beacon. So these are like some nodes that are pulled together and that are aggregated, and in the end you can create one unique result. 200 of these 400 nodes create their signatures, you can put them together, have a result that is random.
It cannot be foreseen who these 400 or 300 nodes will be, because only 200 of them participate in, like only the first 200 are needed to get to that signature, and so it's not deterministic what that signature will look like, or it's not predictable for anyone?
It's deterministic because it doesn't matter which 200 or which 200 subset of 200 nodes will create their signature shares, but it's unpredictable because unless you control these 200 nodes and their signature shares, you cannot foresee what would be the result.
And that's a very handy property for DFINITY, because it also allows us to run the consensus mechanism only on a subset of all nodes. In this example, up to 400 nodes that are part of this signature group. But that also means that a lot less clients are involved in creating the next block than the whole network. And I think that's one of the reasons why we're able to achieve such a short block time versus Ethereum or Bitcoin, where essentially the whole network has a chance at creating the next block.
There are other systems like the classical Byzantine fault-tolerant systems which run a full Byzantine consensus protocol for each block, but they have the problem that they cannot be executed by 400 nodes because it would be too much information that should be sent around. So in our system we can achieve that much more efficiently with our threshold signature schemes, which is very lightweight. And it's not an interactive protocol with 5 rounds where everyone has to send its message at a certain time. It can all be sent in a chaotic way and then aggregated together.
That's the number one differentiator of DFINITY. It's a new consensus mechanism that scales a lot better and is a lot faster than what we've seen in other proof-of-work-based systems, most dominantly Bitcoin and Ethereum. The other key differentiator of DFINITY is that you can run applications on top of it that are more powerful than what we've seen on the other systems. What's one of the key ingredients to making that happen?
To make the system really scalable, we will eventually need to create a sharded blockchain where multiple chains are built at the same time. For that, we will need a system of cross-shard communication, which makes sure that shards can securely communicate with each other, and we also need a system where transactions can be executed atomically. That means if you want to book a hotel and a flight, then you would either want to have both booked or neither of them if one of them is like booked out. So we need a system that ensures that, even with cross-shard communication. But once we have achieved that, we can scale out to much more computational power than a single sharded system like Bitcoin.
How do I, as a developer or someone who wants to work with this supercomputer, how do I get my application onto DFINITY? How do I run it?
So we have this model called actor model, where every smart contract or decentralized application is considered as an actor in the system, and actors can communicate with each other asynchronously by sending messages to each other. Everything can happen in parallel, which makes it much faster to execute all these actor codes on a single CPU because they can run on multiple cores at the same time. So basically you as a developer will create an actor, also create ports to other actors that can communicate with your application, and you can also create ports to external actors like end users or other applications that are not deployed to the blockchain.
And maybe last point that we want to cover is these actors are written in something called WebAssembly. What is WebAssembly?
So WebAssembly is a framework that was developed for web browsers like Chrome, which allows you to run programs in your browser. The idea is that you can use any high-level language if you have a compiler that compiles your code written in any language to WebAssembly. So, and WebAssembly is also like optimized for speed.
So that means if I'm already proficient in C or in Haskell or any other language that I know really well, as long as there's a compiler from that to WebAssembly, I can write in my existing language and then just compile into this WebAssembly byte format.
That's the idea, that you shouldn't rely or be like restricted to one specific domain, specific language. Like in other blockchains, you should have the freedom to choose which language you want to use.
Cool. Thanks, Robert, for your inputs. And with that, I think we're going to wrap up. So I think there's a few key benefits to DFINITY. Number one is the much faster and scalable consensus mechanism kind of at the ground layer. And then on the application layer, DFINITY uses WebAssembly, which allows you to use your existing programming language to write your applications and then compile them into WebAssembly. And with that, we're back to work. So now I'm headed over to the Fox meeting, to my EO forum. We meet once per month, and we always start the meeting with a monthly update where we update each other how this past month has been. And the way we collect this is on paper, and it's a matrix: personal best, personal worst, business best and business worst, friends and family best and friends and family worst. And then we collect 3 columns. Number 1 is what happened, why is it significant, and last, emotions. And that's a great way to reflect on your time, on your past month, communicate that to others. And from that, the idea is always that it would be your best 5% and your worst 5%. From that, we then become conscious of what our presentations should be about the next time. So presentations that we're going to have today, which is another part of this EO forum meeting, those were decided by the monthly updates that we had last month. And then you go through coaching, and so you do the same today. We pick topics that we want to go through next time. If you're looking for a way to reflect on your month, I think it's a pretty simple but effective scheme. And with that, today is a special one. We're on a boat for this first part of the EO meeting. And we're gonna drive on the boat from Zurich to almost the other end of Lake of Zurich, because one of our forum members has a boat, and the weather is just gorgeous, as you can see in the background, and so we're gonna enjoy a nice boat ride. Beautiful location. The only thing is my hay fever is starting to kick in again. I'm gonna have a quick dinner and then gonna head home. So I have another call at 10 p.m. so in roughly an hour from now.